What if the smallest building blocks of reality refuse to follow any rule we understand? In 1925, a 23-year-old scientist made a discovery so strange that even the greatest minds of his time struggled to accept it. And 100 years later, we still cannot fully explain what he found. This isn't a story about a monster or a murder. It's stranger than that. It's a story about the universe itself, breaking its own rules, right in front of human eyes, and nobody being able to stop it or explain why. The man's name was Werner Heisenberg. What he discovered didn't just change physics. It changed the way we understand truth, certainty, and reality itself. The mystery he opened up is still unsolved today. Scientists have spent 100 years trying to explain what really happens inside an atom. Nobel Prizes have been won. Entire branches of physics have been built. And yet, at the very core of it all, there remains a question nobody can answer with full confidence. By the end of this video, you'll understand why one sleepless night on a tiny island changed science forever, and why the greatest physicists in history still argue about what it truly means. This story matters because it touches everything. Your phone, your computer, the GPS in your car, all of it rests on the strange discovery made in 1925, and yet the deepest question behind that discovery remains open. Let's go back to where it all began. In the early 1920s, physics was in trouble. For centuries, scientists believed the universe worked like a giant machine. Planets moved in predictable paths. Objects fell at predictable speeds. If you knew where something was and how fast it was moving, you could predict exactly where it would be in the future. This idea worked perfectly for planets, cannonballs, and falling apples. According to the laws of classical physics, electrons circling a nucleus should lose energy and spiral inward, crashing into the center within a fraction of a second. If that were true, atoms would collapse instantly. Matter itself would not exist. But matter does exist. You exist. This chair, this room, this planet exists. So something was deeply wrong with the old model. Physicists were stuck. They could see the atom behaving in strange, jumpy ways, but nobody could explain why. Electrons seemed to jump from one energy level to another without smoothly moving through the space in between. It was as if they vanished from one spot and reappeared somewhere else, with no path connecting the two. That shouldn't be possible. But that wasn't the biggest surprise. Some of the greatest scientific minds in history were working on this problem. Niels Bohr had proposed a model that partly explained atomic behavior, but it was full of gaps. It worked for simple atoms like hydrogen, but broke down for anything more complex. Nobody could explain why electrons jumped the way they did or what rule they were actually following. Physics needed a breakthrough. It needed someone bold enough to throw away the old rules completely. That person turned out to be a young, quiet, intensely focused physicist named Werner Heisenberg. In the spring of 1925, Heisenberg was suffering badly from hay fever. His allergies were so severe that he could barely think straight in Göttingen, Germany, where he was working. His doctor suggested something unusual. Go somewhere with clean air, somewhere far from pollen and plants. So Heisenberg traveled to a small, rocky, almost treeless island in the North Sea called Helgoland. There was nothing there, no pollen, no distractions, just wind, rock, and silence. Wow. And in that isolation, something remarkable began to happen. Heisenberg spent his days walking along the cliffs, swimming in the cold sea, and climbing rocks. But at night, alone in his room, his mind kept returning to the same unsolved puzzle. Why did electrons behave the way they did? What rule were they truly following? He decided to try something radical. Instead of trying to picture electrons as tiny balls orbiting a nucleus, he would abandon the idea of a visual picture altogether. He would only focus on what could actually be measured and observed, like the light atoms give off, and ignore anything that couldn't be directly seen. This was a shocking idea. For centuries, physics had been about picturing things. Now Heisenberg was saying, forget the picture, focus only on the numbers. One night, working late, something clicked. Heisenberg found a way to organize these measurable quantities into a strange new mathematical structure. It worked. The numbers lined up. The predictions matched what scientists had observed in real experiments. But there was something deeply unsettling about it. According to his calculations, if you multiplied two of these quantities in one order, you got one answer. But if you multiplied them in the opposite order, you got a different answer. In ordinary math, 3 times 4 is the same as 4 times 3. Order doesn't matter. But in Heisenberg's new system, order mattered enormously. He was so shaken by this discovery that he later admitted he felt almost frightened. He said he seemed to be looking through the surface of atomic phenomena into a strangely beautiful interior, and he felt dizzy at the thought of how deep this rabbit hole might go. That night, Heisenberg couldn't sleep, climbed a rock jutting out into the sea and watched the sunrise, knowing he had just seen something that no human being had ever seen before. He had glimpsed the true mathematical skeleton of the atomic world, but he didn't fully understand what it meant yet. He returned to Göttingen and shared his strange new mathematics with his mentor, Max Born, and a brilliant young physicist named Pascual Jordan. Together, the three of them turned Heisenberg's raw insight into a complete new theory. They called it matrix mechanics. It was the first working version of what we now call quantum mechanics, and it explained something that had baffled scientists for years. It correctly predicted how electrons behaved inside atoms, matching real experimental results with stunning accuracy. But here's where the story takes an unexpected turn. Around the same time, a completely different physicist named Erwin Schrödinger developed his own separate theory to explain the same atomic behavior. Instead of strange number tables, Schrödinger described electrons using something called a wave equation. It felt more familiar, more visual. Many physicists found it easier to understand. For a while, there were two competing versions of quantum theory, and nobody knew which one was correct. Then something remarkable happened. Mathematicians proved that Heisenberg's matrix mechanics and Schrödinger's wave mechanics were actually two different descriptions of the exact same underlying reality. Two totally different approaches, same hidden truth. This should have settled everything. But it didn't, because a much bigger problem was about to surface. If matter behaved like this equation and like that number table, what did it actually mean physically? What was really happening inside the atom? Nobody could agree. Then, in 1927, 2 years after that sleepless night on Helgoland, Heisenberg made a discovery that would shake science to its core and become one of the most famous ideas in the history of physics. He proved something almost impossible to believe. There is a fundamental limit to what we can know about a particle at the same time. You can measure exactly where a particle is, or you can measure exactly how fast it's moving. But you can never know both with perfect precision at the same time. This wasn't because our instruments were too weak. It wasn't a technical limitation that better technology could fix someday. Heisenberg showed that this uncertainty was built into the very fabric of nature itself. The more precisely you pin down a particle's location, the less you can possibly know about its speed. And the more precisely you know its speed, the blurrier its location becomes. It's not because we lack the tools to measure it. It's because nature itself doesn't allow both to exist with certainty at the same moment. This became known as the uncertainty principle. It shattered the old dream of a perfectly predictable universe. For centuries, scientists believed that if you knew everything about a system right now, you could calculate its entire future with total certainty. Heisenberg proved that dream was an illusion, at least at the smallest scales of reality. But that wasn't the strangest part. The deeper physicists dug into this new quantum world, the more disturbing the implications became. It wasn't just that we couldn't measure certain things precisely. It seemed like particles didn't even have definite properties until they were measured. Before you look at an electron, it doesn't behave like a tiny object sitting in one specific place. Instead, it behaves like a spread-out possibility, a cloud of potential locations, described by mathematics called a wave function. Only the moment you measure it does it seem to choose one specific location. This idea became known as the Copenhagen interpretation, developed largely by Niels Bohr and Heisenberg together. According to this view, asking where a particle really is before you measure it doesn't even make sense. Reality itself seems undecided until observation forces it to settle. Many scientists found this deeply disturbing, including one of the most famous scientists who ever lived, even if we humans couldn't always calculate every detail. He famously said that God does not play dice with the universe. Heisenberg and Bohr disagreed. They believed the dice rolling wasn't a flaw in our knowledge. It was a fundamental feature of reality itself. This wasn't just an academic argument. This was one of the greatest scientific debates in history, and it never fully ended. The thought experiment suggested that if quantum mechanics were true, two particles could become mysteriously linked, so that measuring one instantly affected the other. Spooky action at a distance, and used it as evidence that something must be missing from the theory. For decades, this remained a philosophical debate, impossible to test in a laboratory. Then everything changed. In the 1960s, physicist John Bell developed a mathematical test that could actually determine, through real experiments, whether Einstein or Heisenberg's camp was closer to the truth. Then investigators uncovered something nobody expected. Beginning in the 1970s and continuing for decades afterward, scientists ran real experiments based on Bell's test. The results were shocking, again and again. The strange quantum predictions were confirmed. Particles really did behave as if they were mysteriously connected, no matter the distance between them. Einstein's spooky action at a distance wasn't a flaw in the theory, it was real. In 2022, 3 physicists were awarded the Nobel Prize in Physics specifically for these experiments, confirming that the deeply strange predictions born from Heisenberg's original 1925 discovery were not mistakes. They were describing something true about reality, however impossible it seemed to human intuition. So here's where we stand today. 100 years after that sleepless night on a windswept island, quantum mechanics has been tested more thoroughly than almost any theory in the history of science. It has never failed a single experimental test. It powers the technology inside every computer chip, every laser, every MRI machine on Earth. And yet the deepest question Heisenberg's discovery opened up remains unanswered. What is actually happening, physically? At the moment a measurement occurs, why does a spread-out cloud of possibilities suddenly become one definite outcome the instant we observe it? What counts as an observation? Does it require a human mind, or a machine, or simply any interaction at all? This is called the measurement problem, and after 100 years, physicists still do not agree on the answer. Some believe the Copenhagen interpretation is correct, and that reality genuinely doesn't have definite properties until measured. Others believe in something called the many worlds interpretation, which suggests that every possible outcome actually happens, but in separate branching universes that we can never see or visit. Still others support alternative theories, involving hidden variables or entirely new physical mechanisms, trying to restore some sense of an underlying definite reality. Every single one of these interpretations makes the exact same experimental predictions. There is currently no known experiment that can prove one interpretation right and the others wrong. It is, in a strange way, not just a scientific mystery anymore. It has become one of the deepest philosophical puzzles in human history. Hiding inside equations that were first sketched out on a remote island in 1925, Werner Heisenberg didn't set out to break reality. He was a young man with allergies, trying to escape pollen, looking for a way to organize a few strange numbers into something that made sense. But what he found instead was a crack in the foundation of everything humans thought they understood about existence. He once said that what we observe is not nature itself, but nature exposed to our method of questioning. In other words, the universe might not have a fixed, definite answer waiting to be discovered. The answer might depend in some strange way on how and when we choose to look. That idea still unsettles physicists today. It should unsettle you too. Because right now in this room, at this exact moment, the atoms making up your body, your phone, this screen, are governed by rules nobody fully understands. Rules that allow for genuine built-in uncertainty at the deepest level of existence. Rules that were first uncovered by a sleepless 23-year-old, standing on a rock, watching the sunrise over a cold, empty sea. 100 years of research, Nobel Prizes, billions of dollars in experiments, and still, the core mystery Heisenberg opened up in 1925 remains unresolved. Not because scientists haven't tried hard enough, but because it may be one of those rare questions where the universe itself refuses to give a simple, final answer. Maybe that's the most unsettling part of this entire story. We built computers, satellites, and lasers on top of a theory so strange that even the men who discovered it couldn't agree on what it truly meant. We use it every single day, and it works perfectly. And yet at its very heart, there remains a mystery no one has ever fully solved. So the next time you use your phone, or see a laser at a checkout counter, or hear about a new quantum computer being built, remember this. All of it traces back to a young man on a barren island, wrestling with numbers that refuse to behave, uncovering a truth about reality so strange that we are still trying to understand it 100 years later. What do you think is really happening at the moment a particle is measured? You think reality has a definite answer we simply haven't found yet? Or do you think Heisenberg and Bohr were right, and uncertainty is simply built into the universe itself? Let me know what you think in the comments below. If this story made you see reality a little differently, hit like and subscribe for more true stories that challenge everything you thought you knew.